So here's a video on how we can find the highest common factor using prime factors. HCF I've written up here, and HCF stands for highest common factor. The highest common factor is the biggest number that's a factor of two or more numbers, the biggest number that goes into two or more numbers. Prime factors, hopefully you know about already. If you don't, there's a video elsewhere that you can watch to check, and I recommend you watch that first before you watch this. Okay, so well, let's find our highest common factor first so you know what we're talking about. Here are two numbers, 12 and 18. Let's just, first of all, just find the factors of 12 and the factors of 18. What numbers go into 12? Well, 1 goes into 12, doesn't it? It goes in 12 times, so 1 and 12 are factors of 12. 2 goes into 12 6 times, so 2 and 6 will be factors of 12. 3 goes into 12 4 times, and after 3 comes 4. I've already got 4 here, which means I've found all the factors of 12. And over here, let's find the factors of 18. Well, 1 times 18 is 18, isn't it? 2 9s, 3 6s. Does 4 go into 18? No. Does 5 go into 18? No. Does 6 go in? Yep, already got it over here, which means I've found them all. Okay, so these are the factors of 12 and the factors of 18. If we look at both these lists, we can see there's a 1 in both lists, as you'd expect, because 1 goes into every whole number, doesn't it? 2 goes into both these numbers. 3 goes into both these numbers. 6 goes into both these numbers. And those are the only numbers, aren't they, that go into both numbers. They're the only common factors of 12 and 18. The common factors are 1, 2, 3, and 6, the numbers that go into both of those. Out of those numbers, 1, 2, 3, and 6, which one's the highest common factor? Well, of course, 6 is. So we would say here that the highest common factor of 12 and 18 is equal to 6. So there we go. That's pretty straightforward with small numbers like that, isn't it? But sometimes you might be asked, or you might want to, for some reason, find the highest common factor of some bigger numbers. And that can get a bit trickier if you do it that way, because finding all the factors of 108 and all the factors of 240 might get a bit heavy for you, and you might not be quite sure of some of your answers. So we can do it in a slightly more easy fashion, I would suggest, by finding the prime factors of each of these numbers and using that information to help us. Let's find the prime factors of 108. What prime number can we divide 108 by? Let's start with the smallest one, 2. Does 2 go into 108? Of course it does, because it's an even number. 108 divided by 2 is 54. That's an even number. We can divide that by 2. So half of 54, 27. Feel free to pause the tape at any stage, by the way, if you want to just answer the question before you hear me answer it. 27. What prime number can I divide 27 by? I can divide it by 3. 27 divided by 3 is 9. Remember, 9's not a prime number. 9's not prime. We have to divide it by 3 to get 3. Obviously, we'll divide 3 by itself to get 1, and when we get to 1, we're done. So those are the prime factors of 108. 2 times 2 times 3 times 3 times 3. Now, 240. Again, it's an even number, so we can halve it. Divided by 2 is 120. That's even, so we can halve that. Gives us 60. We can halve 60 to get 30. We can halve 30 again, can't we, to get 15. 15. What prime number can we divide 15 by? It's not even, but we can divide by 3, can't we? 15 divided by 3 is 5. Well done. 5 is a prime number, so we'll divide it by itself to get 1. When we get to 1, we're done. So there we go. We found the prime factors of 108. Here they are. And the prime factors of 240. Here they are. All right. Now the question now is, are there any common prime factors? Are there any numbers that appear in both lists? And hopefully you can see very easily that, of course, there are. Look, there's a 2 here and a 2 here. There's a 2 in both lists. And actually there's another 2 here and another 2 here. So there are 2 2's in both lists. I can see that there's a 3 here and a 3 here. So there's a 3 in both lists. And looking at the left-hand side, I see I've got 1, 2 more 3's over here. And I haven't got any more 3's over here that I can pair them up with. I've got 1, 2 more 2's here and a 5 here on the right. But there are no 2's or 5's on the left-hand side I can pair them up with. So there are no more prime factors that appear in both lists. There are no more common prime factors. So the only prime factors I have are 2, 2, and 3. There's 1, 2 in both lists, a second 2 in both lists, and a 3 in both lists. Now, if we take those common prime factors, 2, 2, and 3, and multiply them together, that will give us the biggest number that's not prime that goes into both the numbers. And 2 times 2 is 4. 4 times 3 equals 12. Using prime factors, it tells us that 12 is in fact the highest common factor of those two numbers, 108 and 240. Find the prime factors Identify the numbers that appear in both lists, which in this case is 2 2s and a 3, multiply them together, and what you get there will be the biggest number that goes into both lists. It will be the highest common factor. It doesn't just work with 2 numbers, it works with 3 numbers. Let's do an example with 3 numbers. Let's find the prime factor of 36. I'll do it in green. We'll do some different colours. 36 divided by 2, yeah, is 18. We can divide 18 by 2, that's 9. 9's not prime, remember. We'll divide it by 3 to get 3, and 3 again to get 1, so we're done. Let's do 48 in blue, shall we? Yes, I'm using green. 48 divided by 2 is 24. Divide by 2 again, 12, still even, so we'll divide by 2 again to get 6, still even, divide by 2 again to get 3. 3 divided by 3 is 1, and we get to 1, we're done. And finally, 108, we did it earlier, didn't we? Divided by 2 is 54, divided by 2 is 27, divided by 3 is 9, 9's still not prime, so we'll divide by 3 to get 3, and 3 again to get 1, and there we go. There are the prime factors of 36, 48, and 108. The question is, to find the common prime, to find the highest common factor, is which prime factors appear in all 3 lists. Not just one of the lists or 2 of the lists, but in all 3 lists. I can see there's a 2 in all 3 lists, isn't there? And actually, there's another one. Look, 1, 1, 1. So we've still actually got 2 2s in all 3 lists. I can actually see there's a 3 in all 3 lists as well. Now, here's the interesting thing. Okay, and here's the thing to be aware of. I've got a 3 here and a 3 over on the right. But there are no more 3's in the middle, therefore that 3, although it applies in 2 of the 3 groups, is not a common prime factor because it has to appear in all 3 lists. 2 out of 3 isn't enough. For it to be a common prime factor, it has to be common to all the numbers. Okay, so the only numbers that appear in all 3 lists are, again, a 2, a 2, and a 3. Which means actually that this time our highest common factor is going to be the same as it was last time, isn't it? Because it's going to be what we get when we multiply the common prime factors together, which is 2 times 2 times 3, which, as it was last time, is 12. That's coincidence, it's just the numbers I chose. I wasn't thinking when I chose them. But interesting, isn't it, nonetheless? So there we go. I think that's all I've got for you. Yes, that is. That's it for now. That's how you find the highest common factor using prime factors. Find the prime factors, and then find all the numbers that appear in all the lists of prime factors and multiply them together. Good luck with that.